All right. So the second problem, let's move to the second problem now. So the second problem was one about labeling barns. So we have a bunch of barns. We have n less than equal to 5 times 10 to the 5 barns. And they form some sort of like connected network, basically just a graph. They're just a graph. And actually, basically we specifically it's so there's a cycle. So there's a cycle of length k. K is just less than equal to n. And there are two different labelings from Annabelle and Bessie. So A and B. So basically, each person is going to look at this graph and give each like vertex some label from 1 through n, and it's a permutation of 1 through n. So maybe person A labels it like 1, 2, 4, 5, 6, and 8, and person 2 label it, and then they label like there are also some isolated vertices. So they label these ones like 3 and 7. And then the other person or the other cow label it, let's say they label it like 1, 2, 5, 6, 3, 8, and these ones they labeled 4 and 7. Right. So basically, there are different labelings, or basically there are two different labelings on this graph. Now you don't actually know the exact labeling. All you know is that one person or one cow labeled it like a certain order around the cycle, and the other cow ordered a different some ordering around the cycle. So all you know is like what order the labels appear in the cycle, but you don't actually know where the starting point is or which direction the cycle you went in. And now you want to know, basically, what is the maximum possible labels that could coincide between the two cows? So, to give another example, let's say that one of the arrays was 1, 2, 3, and the other one was 2, 3, 1. This is just the order of around the cycle. You don't actually know what the label is, but the labeling for this one could have been that this was labeled 1, 2, 3, and this was labeled also 1, 2, 3, and they just started reading it from here instead of from here. And in this case, this will be 3 labels that coincide, which is the maximum possible for this test case. So yeah, so how can we approach this problem? Well, first things first, before anything else, we can observe that any label not in the A or B, that's just an instantly +1. So if there's a label that does not appear in either A or B, so a label that does not appear inside the cycle in both graphs, in both labelings, then we can just have them both assign that label to the same vertex. And then that's just instantly like +1 to the answer. Now we need to worry about the cycle. So basically, what this is really asking is that like we have two different labelings, and we just need to find a cyclic shift of one of the labelings, possibly with reversing, to make it have the most number of matches with the other labeling. So we just want a cyclic shift possibly with reverse, so that the maximum number of matches. So of course, since n is large, we can't manually try every single shift, but we can observe that in this particular problem, the labels are distinct 1 through n, right? It's a permutation overall. And so that's a pretty big deal because that means that we have like one label, like 1, 2, 5, 3, 4, and the other one was 2, 3, let's say 6, 1, and 5. Then for each one, there will exist a unique position in the other array. And each label for each label inside one of the arrays, there's going to be a unique position that appears in the other array or does not appear at all. If it does not appear at all, then there's no chance of getting that to align, so we don't even worry about it. But if it does appear, say it's 2, then we know that if we shift it by 1, if the shift is equal to 1, then we will get +1 to the answer. So here, if we shift it by 2, we get +1 to the answer. Here, if we shift this one, if we shift it by, let's see, if we shift it by 1, 2, 3, that's also +1. And this one, we need to shift by 1, 2, right? And so what we get here in this situation is that if we shift it by 1, we get 1 alignment. If we shift it by 2, we get 2 alignments. Both the 1 and the 5 line up. And if we shift it by 3, we get 1 alignment. So here 2 is the maximum, so that's the answer we take. Right, so what we can do is we can just go through, instead of trying every single cyclic shift, we just go through each array or each element of the array, check where it exists in the other, check where it exists inside the other array, and calculate just like how much we get shifted by, such the difference between them, mod k, and then put that like +1 to like that shift amount inside like some table. And then at the end, just take the table entry with the maximum value. And then, of course, it is also possible that one of them was red going this way, and the other one could have been going like the other way. So you also need to try like reversing this array and then rerunning the algorithm again. So you can just like run the algorithm twice and reverse the array in between the iterations. And so this will work in O of n time overall, because at the beginning, like checking the ones that don't appear as O of n, doing the cyclic shift, or like calculating for each array, for each element where it exists in the other array, that's also O of n. If you just pre-compute that information, everything can be done in O of n. All right, so any questions on the second problem? Let me see if there are any questions in the chat. It looks like people are also discussing the second problem as well. So yeah.